Everyone. So in this class, we want to talk about clustering, and we will particularly focus on k-means algorithm. So first of all, let me give you one example here. So suppose that we want to find the users that are in the similar groups. So each user, we will use two attributes to describe each user. The first attribute is the time per visit in the units of minutes. For example, when the user go to our website, how long does the user stay in our website, for example, 10 minutes, 20 minutes, or 50 minutes. And then another attribute that we use to describe the user is the spend per visit in the unit of dollar. For example, when the user visits our website, how much money did they spend on purchasing our products? So let's say, for example, we use these two attributes to describe our users. So this is one example. For example, you can have user one, you can have user two, and you can have many more users there. And each user, as we say, we use two attributes to describe each user. For example, for user one spent on average of 12.5 minutes in our website. And then the user one spent around on average of $3.8 on our website, for example. And we also have the same data for user two as well. So now the question here is that how can we group the users when to group those users with similar patterns? If they have the similar patterns on for the time per visit and also the spend per visit, how do we group those users together? So that's the question here. So before we answer this question, let's first visualize the user in vector space. So as we say, we use two attributes to describe the users so we can plot the users on a 2D dimension plot. So for example, in here, the first dimension here, we have average spend per visit. And then another dimension, we have average time per visit. And for example, let's say we have 20 users in total. So you can see each data point here represent one user. So now the question is that which users should be grouped together? We want to group the users that who have similar patterns, right? So we want to group them together. Another question we need to answer is that how many groups are there? One groups, two groups, or three groups? How many groups are there? We also need to answer this question. So we will introduce a widely used algorithm, which is called k-means algorithm. And I will show you the example how to use the k-means algorithm to group the users based on these two attributes. So let's introduce the overview for the k-means algorithm first. First of all, the K here in the k-means algorithm represent the number of groups. For example, we say there are k groups in the data set. That is the K there. And to use the k-means algorithm, we have to decide the value of k by ourselves. So I will show you some examples later. And then the means here in the k-means algorithm name indicate that we will use the mean of cluster to do the data grouping. So what does that mean? So intuitively, mean, you can think of mean as just the centroid or the center of the cluster. And for each data point, we will calculate how close is each data point to the centroid. If and then we will pick the centroid that is closest to data points and use the group of the centroid to group our data points. So let me show you one example here. So first of all, we will use the same data points example here. We have 20 users. We use the same two-dimension attribute to describe the user. Now, initially, as we say, we have to decide the value of k. So let's say we pick the value of k to be 3. We want to group the users into 3 groups. Then initially, we need to initialize our 3 centroids here. So what does that mean? So we can randomly place the centroid. Let's say we place one centroid for the cluster 1, another centroid here for cluster 2, another centroid here for cluster 3. So initially, we can randomly place some the centroid cluster there, and then we will assign the data points to the nearest cluster using the centroid. So you can see, for example, for the first centroid of the cluster 1, we assign these data point to this cluster because they are closest to the first centroid. And similar idea, this is the same thing. And also our centroid, another centroid, the blue centroid is here. You can see all other data, these data points, they are closer to the blue centroid. That's why they are all blue. Okay. So in summary, we assign the data point to the nearest cluster by using the distance between the data points in the centroids. Then after we assign the points to a cluster, now we want to update our centroid. So we want to update our centroid because now we have a new cluster, right? We have a new update cluster. So the centroid, the center point of the cluster will change. So as you can see now, this, for example, this centroid now moved to here. It moved a little bit because now we have a new data point belonging to this group, belonging to this cluster. And the blue one is the same thing. Previously, we have this blue centroid here. Now, after updating the blue centroid, now it becomes toward to the right because now we have new members joining this cluster. So we update the centroids. Now we have the new centroid. Now we will repeat assignment again. We will use the new centroid to assign the data point to the nearest cluster using these new centroids again. So you can see previously this data point, they belong to the blue cluster, but because the blue cluster now moved to the right, so now if we do the assignment by recalculating the distance between the data points and the centroids again, these data point previously belonging to the blue cluster now will belong to the brown cluster. So we just need to redo the assignment again using the new centroids. Now, after that, we repeat the same thing. We will update our centroid again using the new data points joining the cluster. So now you can see the centroid for the brown move a little bit to the middle. And then this blue one also moved to here. Okay, so you can see the two centroids have been updated. Now we repeat the process again. We assign the data points again to the new centroid. Then after that, we update the centroid again. Now you will notice one thing, that the centroid, after we updating the centroid, this centroid, they remain the same, right? They remain the same. So that means there's no change to cluster, and also the centroid doesn't change. That means there's no new updates. So when we see the centroids remain the same, they don't change, then we can stop the algorithm because we know that even if we keep running the algorithm, nothing will change. So we can stop the algorithm. Then we have our clustering. Now we just divide our users into 3 groups, 3 clusters. The first cluster, the second cluster, and the third cluster here. So that's how K-means algorithm works. Now, the next question is that we want to measure the quality of the cluster, right? Because the K-means algorithm doesn't always give us the optimal solution. So we want to measure how good is the solution given by our K-means algorithm. So there's one metric that we can use. To determine how good is the clustering result, we will want to measure how compact each cluster is. So what does that mean? For example, let's use the same example here. We have 2 clusters, right? So the compact here is just that how close of each clustering members towards the centroid. The closer they toward to the centroid, the better the quality. That means you have a better group, right? So in here, I use this ellipse area to represent the compactness of the cluster. So we can see we have this first cluster close to the centroid, and also we have this blue one close to the centroid, and we have this brown one close to the centroid. Okay, so we can see the brown cluster is more compact than the other two clusters. Now, K-means algorithm has some limitations here. As we say, the K-means algorithm doesn't always give optimal solution. It doesn't always give the optimal solution. And the solution quality depends on two main factors here. First of all, the solution depends on how do we place our centroid initially, right? Because different placement will give us different solutions. So I will show you one example later. And also the quality of the solution depends on the value of K, which is the number of classes. If you say we are going to divide the users into 3 classes, 4 classes, or 2 classes, that will also give you different quality of solution. So let me show you one example here. Let's say if we use different initial centroid placement, what will be different? So this is our example, right? Initially, we have the initial centroid here, 2 centroids here. And then at the end, we have this result. That's the compactness of our classes. Now, let me show you another example. What if we place our 3 centroids in a different way initially? Then you can see that now they give us a different solution, right? They divide the user point into into 3 clustering in different ways. So which one is better? We need to calculate the compactness of the cluster and take the average. But you can see the different way we place the initial centroids will give us different solution, and then the solution will give us different quality. So that's the idea. Now, second, if we use different values of K, which means that if we decide to use different number of cluster, the K-means algorithm will also give us different solution with different quality. So the same thing, using our original example, we set K equal to 3, right? Because we say that we want to divide the data points into 3 clusters. So this is our solution here. Now, what if we change K to be 2? Then then in this case, we only have 2 classes. So at the end, the data points will be divided into 2 classes. So you can see now the blue one is less compact than the blue one using K equal to 3. Because now we have fewer groups. So that means some of the cluster they may have a larger distance. Now, you may ask, maybe we want to use more classes, right? Maybe we can set K equal to 4 to get a higher number. So what if we set K equal to 4? What will happen? So you can see we have 1 centers here, 3 centers here. At the end, we have 1 cluster, 2 cluster, 3, and 4. Now, some people may have the concern here is that do we really need 2 clustering for this group of data points? Because they are already very close. Do we really need to have 2 clustering for that, for those data points? That's the question. Maybe if we change the initial centroid placement for k equal to 4, maybe there will be a different result. So you can see for K-means algorithm, because it doesn't guarantee optimal solution. So usually in the common practice, people will need to try different K values and also try different placement to see which parameters will give them the best solution. So they have to try different solutions. So that's the idea. And that's everything for this class. Thank you.